This is section 6.3, proving that a quadrilateral is a parallelogram. So when we finish, we want to be able to determine whether a quadrilateral is a parallelogram given certain characteristics. Okay, so the essential understanding for today is to understand and know that you can decide whether a quadrilateral is a parallelogram if its sides, angles, and diagonals have certain properties. And today we're going to talk about those properties. Okay, the first one is Theorem 6.8, and it says if both pair of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in this one, we have BC is congruent to AD, and we have AB is congruent to CD. So that lets us know that ABCD is a parallelogram. Now let's take a look at 6.9. So this theorem says if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So remember one of our previous lessons, we learned that consecutive angles are supplementary. So this is saying that if A is supplementary to B, and A is also supplementary to D, then we have a parallelogram. Then both opposite sides are parallel to each other. Okay, now on to Theorem 6.10. So you're going to want to spend some time reviewing these theorems to make sure you can remember. Just you don't have to know it verbatim, but you do need to have a good understanding of what happens. So Theorem 6.10 says if both pairs of opposite angles, so opposite angles, are congruent, then the quadrilateral is a parallelogram. So if A is congruent to C and B is congruent to D, then we know we have a parallelogram. Okay, so now let's take a look at this problem. For what value of y must PQRS be to be a parallelogram? Okay, so I'm looking for y. So if these are parallelograms, I know that PS and QR must be congruent, and I know that PQ and SR have to be congruent. Okay, so when I look at PS and QR, I have two variables, so I can't use that one. When I look at PQ and SR, I have the same variable. I have X here and X here. So if this is a parallelogram, then I know they have to be equal. So I'm going to say 3x minus 5 is equal to 2x plus 1. I'm going to subtract 2x from both sides. So then I have x minus 5 is equal to 1. I'm going to add 5 to both sides. So I get x is equal to 6. So now I'm going to say x plus 2 is equal to y. My x value here is 6, so I'm going to say 6 plus 2 is equal to y. So 8 is equal to y. So in order for this to be a parallelogram, y has to equal 8. Okay, on to another theorem. So now we have Theorem 6.11. So this theorem says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And remember, when we say bisect each other, it means to cut into two congruent pieces. So AE is congruent to EC, BE is congruent to ED. So if that happens, then we have a parallelogram. Okay, so now we're given segment AC and segment BD bisect each other at E. can we determine that ABCD is a parallelogram without using Theorem 611, without using the angle bisector theorem? So let's see. So let's do our markings. So these are congruent. AE is congruent to EC. So we want to see if we can reason and determine where ABCD is a parallelogram. Now we know a lot more than we think we do. So let's look. BEA is congruent to which angle? CED. So let's write that down. So angle AEB is congruent to angle CED. Now what else do we know? Well, we know that BEC is congruent to angle AED. Now let's take a look. Let's take a second and see what else we know. Do you see it yet? I have side, angle, side, side, angle, side. So these two triangles are congruent. So that means that BA is congruent to CD because corresponding parts of congruent triangles are congruent. So I know that triangle AEB is congruent to triangle CED. And notice that we lined up the congruent pieces. So AE is congruent to CE. So that's really important when you're naming your congruent figures. So now let's see what else we know. So the other thing we know is triangle BEC is congruent to triangle DEA. So then we can also say that segment BC is congruent to segment AD because congruent parts of congruent triangles, same parts of a congruent triangle are congruent. So because this quadrilateral, opposite sides are congruent, both pair of opposite sides are congruent. So that makes it work. Now let's take a look at Theorem 612. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. Okay, so these are congruent, meaning the same length, and they're also parallel. Now let's take a look at this problem and decide whether the quadrilateral is a parallelogram. Okay, so AB is 5, CD is 5. So I know that segment AB is congruent to segment DC. What am I missing? So I've got the measure of angle A is 50. The measure of angle D is 130. So now what? Can I say that these are that ABCD is a parallelogram? Well, let's extend this side out just a bit. We're going to pretend that's straight. So if these were parallel, what would happen with my same side interior angles? My same side interior angles would be supplementary or equal to 180 degrees if AB was parallel to DC. Does that happen? It does. So 50 plus 130 is equal to 180 degrees. So I now know that yes, this is a parallelogram. Now let's take a look at B. HI is congruent to HK. JI is congruent to KJ. I want to know if HIJK is a parallelogram. What do you think? So the answer is no. Tell me why it's not. Because the opposite sides are not congruent. Adjacent sides are congruent, and that doesn't help us any. Okay, let's take a look at problem 3. We want to, let's read it. Identifying parallelograms. So a truck sets on a platform of a vehicle lift. Two moving arms raise the platform until a mechanic can fit underneath. Why will the truck always remain parallel to the ground as it is lifted? Why do you think? Well, this angle P changes. Angle S changes. But does the length of PQ and SR change? No, it remains 6 feet on both. Does the length of PS and QR change? Nope. It's the same on both. So opposite sides are congruent. So I have a parallelogram. Okay, so the first thing I want you to do, this is a summary of, and I want you to scratch out proving, and I want you to put in determining. Determining that a quadrilateral is a parallelogram. So this is a summary of all of the theorems that we've done in this lesson. So if both pairs of opposite sides are parallel, you know you have a parallelogram. If both pairs of opposite sides are congruent, then you know you have a parallelogram. If an angle is supplementary to both of its consecutive angles, then you have a parallelogram. If both pairs of opposite angles are congruent, then you have, guess what? A parallelogram. If the diagonals bisect each other, then you have a parallelogram. And finally, if one pair of opposite sides is congruent and parallel, then you have a parallelogram. So each concept is probably, I wouldn't say they're that difficult, but there's a lot of them. So I like to call this material dense. So you will need to make sure that you can remember all of the methods that you can determine that a quadrilateral is a parallelogram.